Alright, so this will be a review on the sum or difference of two cubes. So for the sum, we get that a cubed plus b cubed is factored into a plus b in parentheses times a squared minus ab plus b squared. And then for the difference, we get a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. Okay? Now note, let's just fix this real quick. Now note that this sign right over here and this sign right over here is the same. Similarly with this, the sign here is the same as the sign here. And then notice how the sign here, okay, the sign here will be the opposite of the sign here, and it's the same here. Okay, so that's why if you have a cubed plus b cubed, okay, you can always put down an a here. You don't know which sign is here, but you know there's a b there. You know that there's an a squared here. You don't know what sign is here. An ab plus b squared, okay? That's what you know. And then recall that this is the same as this, so you get a plus here. And then recall that this is the opposite of this, so you get a minus. Okay? Now I'm going to show you how to come up with this formula. So let's look at the x cubed plus, what's your favorite number? 3? Okay, 27. Okay, which is of course equal to 3 cubed. To factor this, one thing we can do is we can use the irrational root theorem or the irrational zeros theorem in order to find a root. And then once we find a root, we can get our factor, and then we can do division, right? So here I'm going to set this equal to 0 so that I can solve. I'm gonna minus 27 on both sides, and then I get negative 27 equals x cubed, and then now I'm just going to take the cube root on both sides to get that negative 3 is equal to x, right? And then we can rewrite this as x plus 3 by adding 3 on both sides is equal to 0. And then this right here will be our factor, right? So now we can just divide it by x plus 3. Now I'm going to use synthetic division because we're dividing by a linear term, so I think it's easier. For Sasaki, we will set up our synthetic division like that, and then for Cropsey, we will set up our line division like that. In both cases, you put the 0 of the dividing term in the box, in the place where you put it, so here and here, and you put your polynomial. So for our x cubed term, we have a 1. For our x squared term, we have 0. For our x to the first power term, we have 0. And then for our constant term, we have 27. And then, of course, that will be the same over here. So here, we just drop the 1. So we get 1. Then we multiply this, and then bring it over here. So here we get negative 3. And then we add negative 3. Here we times this, and then put it up here. We get 9. You add 9, and then you do this times this, which is negative 27, put it up here, and then of course you get your 0, happy face. And then just to clear it up, right? So yeah, we get your happy face too. So now, we have to recall that x cubed plus 27, at first we divided by x plus 3 because that was our factor. So x plus 3 was what we got first. And then note that we divided a cubic by a linear term, so it will be 1 degree less. So this will be, and then of course this is our constant term. This will be what our polynomial looks like. Okay? So here we get x squared minus 3x, and then we get plus 9. Okay? And that is how we come to our formula. So here, if we let x to be a, and we let b to equal to 3, okay, we get that a cubed plus b cubed equals a plus b times a squared minus b times a plus b squared. And of course we can rearrange this, we can swap orders to get your clean formula. I'll just do it now. And of course this works the same if you had a, let's first say, if you wanted to come up with a cubed minus b cubed, right? You just look at a polynomial like x cubed minus 27. You do the same steps, but then you get that x minus 3 is your factor. You do synthetic division or long division, and then of course you get that a minus b, a cubed minus b cubed is a minus b times a squared plus ab plus b squared. Yep, and then if I move it down here, except for my handwriting, those are your clean formulas. Of course, if you forget this on your test, you can always, what you should do is skip it, finish all of the other questions that you know, and then come back to this and spend a little bit more time on deriving the formula, so you can then solve. I hope I helped you remember it and better understand how we got these formulas, and good luck with your studies. Okay, bye.